All right, we are going to finish up our area diagrams today and even maybe start a little factoring. So, this first top half of the problem is just review from yesterday. Go ahead, fill in all those boxes, and then write your answer as the area as a product and the area as a sum. So remember to do these boxes. We just multiply the length times the width of each one. So 3 times 4 gives me 12. 3 times 5. And just a reminder, right, if this side is 3 over here, that means this is 3, which means this is also 3. This is 2. This is 5. This is 4. So 5 times 3 then would be 15. 2 times 4 is 8. And 2 times 5 is 10. So my area as a product would be adding the sides up and multiplying them. So 3 plus 2, that would be this side, 3 plus 2, and then this side would be 4 plus 5. Three plus 2 is 5, 4 plus 5 is 9, for an answer of 45. The area is a sum. We just add up all the inside boxes. So 12 plus 15 plus 8 plus 10. And when you add that up, you do get 45. All right, and this next box is going to look almost identical to the top problem, except now we have an x here and an x here. So we're adding x's, we're adding variables to our boxes. So not much is going to change here. 4 times 3 is still 12, but this time x times x is x squared. 5 times 3 is still 15. But here we have an x with no x's. So how many x's do we have? Just 1. 4 times 2 is still 8. How many x's do we have? Well, we've got just the 1. And 5 times 2 is just 10. No x's to deal with. So my area as a product is going to be 3x plus 2. Right? You add the sides. Then you add the top. 4x plus 5. My area is a sum. Just add up all the boxes. 12x squared plus 15x plus 8x plus 10. And we actually can simplify this right here. Right, 15x plus 8x, so we can rewrite that as 12x squared plus 23x plus 10. And don't forget, we do know that those things are equal. All right, so the next box says, write an equivalent statement for the area as a product and the area as a sum. And then how can we use the distributive property with this? So I'm going to go back to the last problem, but I'm going to answer it here. And if you look at this, this is exactly what we did last unit when we were multiplying binomials. So notice we had a 4x plus 5 times a 3x plus 2. It looked a lot like this in the work, and you were able to multiply it out, and you got this. So this is just distributing again. We've talked about this. So it's 3x times 4x and 3x times 5, and 2 times 4x and 2 times 5. We're just distributing each one of those, but as we did some of the work last unit, we did use a box to help get our answer. So this is kind of where it's all coming back now and all coming together is with these boxes. So for this, you don't necessarily need to write anything, but how can you use distributive property? We can do our double distribution. That's B. All right. All right, here are some more kind of like practice problems. So go ahead, fill in the insides of the boxes, and then see if you can write the area as a product as a sum. Feel free to pause the video if you want to try it on your own. Otherwise, go ahead and I'll do these two, and we'll go through them. So 2 times 3 is going to be 6. X times x is x squared. And then for the other box, 2 times 7 is 4. And then we have an x, 14. Then we have an x. So area as a product, 2x times the top. And that's going to equal my area as a sum, which is 6x squared plus 14x. And as we talked about, that's just distributing, right? So we did distributed here, we distributed there. Next one, we got our 4 boxes here. So once again, just do the math. Remember there's an invisible 1 here. So 6 times 1 is 6. X times x is x squared. 1 times 1 is 1. And we have our x times no x's. 6 times 2 is 8. And then we have our x. And 2 times 1 is going to be 2. So area is a product. So we have our x plus 2 from the side. And then we have 6x plus 1 from the top. And that's going to equal our 6x squared. Just a reminder, we combine like terms. So 1x plus 8x, I'm going to combine those to get 9x plus 2. So for these problems, when we have some x's, we're not going to get just a solid answer. The answer is 5 or something like that. You'll get x's in your answer. All right, and for this one, go ahead and try this one on your own. Pause the video. When you come back, you'll see the answer. All right, so we have our x squared. We have 5x, and 25. So area of the product, my left side is x plus 5. My top is x plus 5. And then we write the inside of the box is x squared. We want to add 5x plus 5x, combine those like terms to get 10x, and then 25. And part D, explain why the rectangle part C, which we just did, is known as a perfect square. And if we look at this, since both of these things are the same, we could say that this is x plus 5 squared. So remember, we even talked about that last unit, where if we see that, then we can break it down into x plus 5 times x plus 5. So that's why we call it a perfect square. X plus 5 squared. All right, so this is exactly what we just did. It's just putting the information on the blanks. So for this first problem, I'm going to put my 2x here because that's my side. And then put my 4x and then my plus 1 there. Go ahead and do areas of sum. Go ahead and pause the video. When you come back, you'll see all 3 of these problems done, A, B, and C. So you can take a look at it then. All right, here we go. Just a reminder that it doesn't matter which one you put where. So I put x plus 2 here. I put 3x plus 2 on top. If you did it in reverse order, you're still going to get the same answer. So you should still get this answer even if you put the 3x plus 2 on that side. And here's the last one, part C. All right, so today we started kind of bringing everything together with these boxes. We've been using them for a month now or so. And tomorrow we are actually going to start factoring. And you'll see that we're going to bring back the x and we're going to use the box as we start our factoring.